Hello, I am Ferzan Kara. I am shooting this video for the third assessment of the Design and Analysis of Algorithm course. I ask a question for ChatGPT and can you give me a basic practice question on master theorem? And certainly here's the basic practice question related to master theorem for solving divide and conquer recurrence. Solve the following recurrence relation using the master theorem, this one, and please provide the solution using the master theorem. The master theorem is a technique used to analyze divide and conquer recurrence relation of the form, and this form is Tn equal a Tn divided b and plus Fn, this one, and Tn represent the time complexity of the algorithm, and this one is the number of the subproblems. This one is size of each subproblems, and Fn is this one, the time spent on dividing the problem and combining the result in your recurrence relation. Now let's compare to the master theorem form. First one is I ask a formula and Tn is this true? The true formula. Yes, the formula is the private, is the correct. Okay, according to this one and this formula, A equal to 2 and B equal to 2 and Fn equal to n square. Yes, this is great. Have your values. And now we can calculate the log Bn. Actually, according to master theorem, we have three cases, and in our cases, Fn equal to n square and n square log Ba n. Since Fn and n square log Ba are of the same order, and therefore the solution of the recurrence relation is, I think Tn, I ask recurrence relation is this true? I ask. Actually, it's true because say that the correct solution your recurrence relation is O(n) log and log n, so equals to O(n) log n. I said that, and so the time complexity of the algorithm is needed O(n) log n, not Tn O(n) log n. Okay. In the big O notation, O(n) log n is the upper bound of the time complexity, meaning that the actual time complexity does not grow faster than n log n. Therefore, both Tn equal to O(n) log n and Tn equal to O(n) log n are correct statement about your time complexity of your algorithm. Okay, now ask another question. for homework. Sorry. Can you give me a basic practice question, recurrence relation? Okay. Question is, can you give me a basic practice question on recurrence relation? Question is this one. Find the solution for Tn in terms of n. Okay. I understand, but a little bit I confused, and I want help for ChatGPT and ask, can you guide me without giving the whole solution? Okay. Of course, I will guide you to step the sole solution recurrence relation without providing the complex solution. Identify the form. Okay. This relation can be expressed that. Okay, I know this. I said before this one, and in your cases, a equal to 2, b equal to 2, fn equal to n. Okay, I know this one, but I don't the other one. I read compare fn to n log bn in the master theorem. You need to compare fn n log n a, and in this case a equal to 2, b equal to 2, so log ba equal to log 2 equal to b. Okay, determine the relationship, and case 1 this one, and this solution is Tn o log n. Okay, and case 2 is this one, and case 3 is this one. Okay, I understand actually, and apply the approach case. Determine which case the relation fit, and based on that provide the solution for Tn in terms of n. Okay, I think now to solve the given recurrence relation, Tn equal to 2t n divided 2 and plus n. We can use the master theorem, which is a common method for solution recurrence relation of this form, and the master theorem provides a simple and effectively way to determine and time complexity of divide and conquer algorithm. I know this one, and okay. I think so. According to master theorem, the solution for the given recurrence relation is O n log n. Actually, I said this one. O n. Sorry. Time complexity. Sorry. I. Okay, but I'm correct. Okay, a time complexity of O(n) log n. Thank you for your solution. Okay, thank you. And I ask a medium problem. Can you give me a medium practice question on master theorem? Okay, the question is this one. Using the master theorem, determine the time complexity of this recurrence. Please provide the solution. Explain the step you took arrive the answer. This problem is a little more changeable because it recurs. You apply the master theorem to specific recurrence relation and analyze the relationship between A, B, and Fn. Okay. Okay, this question is a little bit hard for me, and I ask help and okay. First one is identity form. Actually, this one is the same other question. And apply the approach case. Excuse me. First one is identiform. Okay, I know A is 9, B is 3, and Fn equal to n square. Okay, I know this one. And compare this one. Okay, and calculate this one. Okay, and determine the relationship. This one, and apply the approach cases. Okay, to solve the given recurrence relations, this one, and using the master theorem. Okay, that I will follow the same step as before. And so, according to master theorem for the solution for the given recurrence relation, I think is O(n) square log n. I think I ask this one. Of algorithm describe recurrence relation. N square divided log n. Is this true? Okay, the correct time. I think I'm not correct. Okay, I read the correct. The time complexity you mentioned O(n) square log n is not associated with the recurrence relation. Okay, for the particular recurrence relation, the correct time complexity is O(n) square, not log n. The master theorem was designed for recurrence relation with the form Tn equal. Okay, I know this one, and it is used to analyze, determine, and the time complexity of such relations. In this case, the time complexity of the given recurrence is O(n) square because it falls into case 2 of the master theorem, where O(n) square and log BA. Okay, so the time complexity of this one, O(n) square. Okay, I understand. Now I ask, can you give me a medium practice question on recurrence relation? Okay, this was the recurrence relation, and I think I asked something. I know the formula Tn, and this is the A. So A is 2, and B is 2, and Fn is n log n. I know this one, and okay. Actually, I know the other question, and I know this step, and I use this step, and I think this is the second case. Is this one? And therefore, the solution for the given recurrence relation is Tn equal to 2t and divided 2 and plus n log n is actually Tn equal to O n to n. I think this one I ask, is this true? Because I said I use the. I think this question is use the case 2, and okay, I ask. Okay. Um, actually has the time complexity of n. Okay. Says not o n log n, but I say o n log square. So I think it is true for as said. So the correct time complexity for the given recurrence is o n square n. Okay, this is not problem. I say this one, and now I ask, can you give me a hard question on master theorem? Okay. I know it is a is 2, b is 2, and fn is n square log n. I know this one. And okay. Okay, I know the step. I don't ask repeat and repeat. This is the step. And I know the cases. And I think for this question is I think use master theorem case 2, additional logarithmic function, and I think this one. And okay, for this question, in this case, fn is n square log n, and so we have tn is equal to o n square log square n. I think is this true, but okay, the time complexity of the recurrence relation, this one, is indeed it. O n square log n square, as you have mentioned. So your statement is accurate. The correct time complexity if the recurrence is okay, this is true, which means the algorithm runtime grows at the most n square log square and in the worst case. Okay, I think it's true. And the end of the question is, can you give me a hard practice question on the recurrence relation? Okay. Okay. I said A is 2, I know this, B is 4, and Fn is this one. Okay. But I will ask this one because I don't know what is this case. Okay, to solve the given recurrence relation is, we can use the master theorem, we know. And however, the master theorem is not directly applicated in this case because it is designed for recurrence relation with a specific form, I think. But I will ask some help because I don't know what is this case and square root. I don't know, and I will ask some help. I know this one, but given the square root term in the recurrence, you may need to explore alternative methods such as substitution, recurrence tree, or iteration, and try to simplify or manipulate the recurrence to analyze to determine the time complexity. This recurrence is a little more changeable due to square root terms, so you will need to carefully examine the relation between the time complexity. Okay, I will ask to explain her answer to me nicely because I have no idea about the subject, how to solve square root. Okay, and please explain the answer. Okay, I know this one. I said this one. A is 2, B is 4, and Fn is square and square root and recurrence 3 method. This one I don't need this one. And each level of the recurrence divided n by 4 and b is 4. Okay. At each level we have two sub-problems and work done at each level is square and square root, and you can visualize the recurrence tree. Observe that the number of the level is the log 4, and since the input size is divided by 4 each level, now we can sum up the work done at each level, which is n square root and log 4 n levels. Therefore, the time complexity can be approaches and use this one. And the last one is runtime grows at most. Recurrence relation is approximately n square root n log n ln n. Sorry. Okay. Yes, we have come to end our question. We have solved simple, medium, and difficult question about master theorem and recurrence relation. Thank you for your listening to me.